Okay, so we are moving on to radians and reference angles. So we did reference angles with degrees. Now we're going to do them with radians, although we're actually going to use our degrees to help us with our radian reference angles. Okay, so when I'm drawing an angle in standard position with the measure of the following radians, first thing is to get a gauge of where we are, you should convert your radians to degrees. Now that's not required, but sometimes that's really helpful if you're drawing angles and you're not really strong with fractions. So draw terminal side in the appropriate quadrant. So then after we know where I'm going, we should draw our terminal side in that quadrant and construct an angle with the initial and the terminal side connected at the origin. Okay, so pi over 4. Now, I know that this is 0, and it's helpful to know your quadrantal angles. This is pi over 2. This is pi. This is 3 pi over 2. So if you think about it as this is 1 pi over 2, 2 pi over 2 is just pi, 3 pi over 2, 4 pi over 2 is back to 2 pi, okay, if we're going around the circle. Okay, so pi over 4, if this is pi over 2 or half pi, then this is really 1/4 pi. And 1/4 pi is going to be halfway between 0 and 2 pi. So this angle right here is pi over 4. Okay, so we didn't need to convert that one. Now 7 pi over 6, maybe that one's a little trickier, okay? But we know that pi over 2 is here. Sorry, 0 pi is here. This is 1 pi, and here's 3 pi over 2. 7 pi over 6, it's more than 1 pi, but probably not as close to 1.5 pi. So we know it's going to be in quadrant 3 somewhere, but let's just see. So 7 pi over 6, if I multiply that by 180 over pi, the pi's are going to cancel. 180 divided by 6 is 30, so times 7 is 210 degrees. So 210 degrees, remember this is 90 degrees, and this is 270 degrees. So we're closer to 90. We're going to draw our initial angle here, or I'm sorry, our terminal side in quadrant 3, and this would be our rotation of 210 degrees, or 7 pi over 6 radians. Okay, 5 pi over 3. So now my denominators are a little bit different. So here's pi. Here's 3 pi over 2. Here's 0 and pi over 2. I know I went in a weird order. Let's convert. So 5 pi over 3 times 180 over pi to get the pi to cancel. Okay. 180 divided by 3 is 60 times 5 is 300 degrees. So this I know is 270 degrees. So 300 degrees, and this is 360 degrees, 300 degrees is going to be closer to 270, so we're going to be in this quadrant here. Let's draw our initial ray, but I'm going around this way, so here's my 5 pi over 3. Okay? So those are how you draw an angle in standard position. So now to find the reference angle, we're going to first convert our radians to degrees per the usual. Okay. Identify the appropriate quadrant and then find the reference angle. So if the reference angle is in quadrant 1, then we just use the angle. It's equal to theta. If we're in quadrant 2, we take 180 degrees minus theta. If I'm in quadrant 3, we take theta minus 180 degrees. And if I'm in quadrant 4, I'm going to take 360 degrees minus theta. And then I'm going to convert back to radians. Okay, it's not the best way, but it's better than maybe subtracting with fractions. Okay, so if I want to convert 3 pi over 4, or find the reference angle, first of all, where is that angle? So 3 pi over 4, if this, it's 3/4 pi. Well, here's pi, here's 0. So this is half pi, which means that 3/4 pi is right over here. Okay, so this is 3 pi over 4. The reference angle is here. So we're in quadrant 2. Remember, reference angle. The reference angle goes, is taken to the x-axis. So here is from the terminal side to the x-axis. This is the theta that I'm trying to find. So if I take 3 pi over 4 times 180 over pi, cancel out your pi's, and then we're taking 180 times 3, 180 times 3 divided by 4, and so we have 135 degrees. So 135 degrees, since that's in quadrant 2, I'm going to follow the quadrant 2 rule, which is 180 degrees. So RA is equal to 180 degrees minus 135 degrees, which is a 45 degree reference angle. And then we're going to take that and we're going to convert it back to radians. So we're going to flip our multiplication, and so we get pi over 4. Now that I feel is kind of complicated. It'd be easier if I knew how to subtract fractions. So let's try number 5, maybe using the fraction way. If I know 180 is pi, then let's do pi minus theta. Let's do theta minus pi. And for this one, we would do 2 pi minus theta. Okay, so maybe let's work with using radians for this one. So 7 pi over 6. Didn't I do that one? 7 pi over 6 is in quadrant 3. All right, so I know that I am over here. So here is 7 pi over 6. So the reference angle is going to the x-axis. So if I'm going to, in quadrant 3, that's the reference angle is equal to whatever theta is, the angle minus pi. So 7 pi over 6 minus pi. Well, I need a common denominator, so let's multiply this by 6 over 6. So I get 7 pi over 6 minus 6 pi over 6 is just 1 pi over 6. And there's your reference angle. That wasn't so bad, right? The trick is if you know if it's more or less than 1/2 pi, 1 pi, 3/2 pi, or 2 pi, or 0. If you can, oops, I'm outside the range there. If you can identify where you are, then that's going to be helpful. So if I have 4 pi over 9, is 4/9 more or less than pi over 2? Or more or less than 1/2? Well, 4 over 8 is less. Excuse me, sorry about that, guys. So 4 over 8 is 1/2. 4 over 9 is less than 1/2, which means that I'm in quadrant 1, So this is my, it's going to be over here somewhere. If I'm in quadrant 1, the reference angle is the angle. There's no work required. It's 4 pi over 9. Okay? All right. So now for the next step, find the exact value of theta, or exact value for sine and cosine and tangent for each angle. So we could use this conversion of radians to degrees. This is always a backup plan. I might try and work in radians for this, but I'll show you both. So then find the reference angle, construct your triangle. We're going to use special right triangles, label our sides, and then use the ratios, or SOHCAHTOA, to find the trig ratios. So remember, 45, 45, 90 degree triangle is x, x, x root 2. Oops, I wrote a 3, but it's a root 2. Okay. In a 30, 60, 90 triangle, it's x, 2x is the hypotenuse, and x root 3 is the long leg. Okay, so we need to know that. So, 45, for 4 pi over 3, we need to know where we are. Okay, so 4 pi over 3, we are more than pi. Because here's pi. Oops. So here's pi. Why do I keep doing that? Sorry, guys. Here's pi. Here's 3/2 pi. 4 pi over 3, it's more than pi. So we're going to be over here. We're going to take this angle. There's 4/3 pi. So after we find the angle, we're in quadrant 3. So quadrant 3 tells me all students take. So T is our focus. So tangent is going to be my two positives. So tangent theta and cotangent theta are going to be my two positive ratios. Everything else is going to be negative. All right, so now let's find this reference angle. So the reference angle, if I'm in quadrant 3, that means that I'm taking theta minus pi. So I'm taking 4 pi over 3 minus, let's convert that to have the same denominator. So it's going to be 3 pi over 3, which tells me I have pi over 3 is my reference angle. Convert that into degrees. So I'm going to do 180 over pi. Pi cancels. 180 divided by 3, that's 60 degrees. So the reference angle should be a 60-degree angle. Okay, so what we do is we create this triangle with this angle right here as a 60 degrees. I didn't draw that very well, so I'm actually going to erase it because a 60-degree angle should be much deeper. So I'm going to make this 60 degrees. Okay? All right, so then what happens is, here's, because I'm a 60 and I have a 90 because I drew in my perpendicular, then this is 30. So here's x, here's 2x, here is x square root 3. Okay, and since we're in quadrant 3, this should be negative and this should be negative as well. Since the ordered pair, I'm going left and I'm going down. Okay, so then sine. So sine of theta, in this case, sine of 4 pi over 3 actually, because that's the angle, is equal to opposite over hypotenuse. So we're taking the x root 3 over 2x. So I get negative x root 3 over 2x. The x's cancel, and you're left with negative root 3 over 2. Cosine Actually, now that I think about it, I only need to find sine, cosine, and tangent, right? I don't need the reciprocal functions. Cosine, switch back to purple, of 4 pi over 3 is equal to adjacent over hypotenuse. So go back to your 60, and I'm taking negative x, which is my adjacent side, over my hypotenuse, which is 2x. The x's cancel, and I'm left with negative 1/2. And then lastly, my tangent, I'm going to cotangent, it's positive, and it's 4 pi over 3, is opposite over adjacent. So I'm taking negative x root 3 over negative x. The negative cancels, that's why it becomes positive. The x's cancel, and I'm left with the square root of 3. So final answers are sine is square root of 3 over 2, cosine is negative 1/2, and tangent is the square root of 3. Okay? So it's kind of a messy process. There's a lot to remember in working with fractions. But we're going to get real familiar with some of these values very soon. Okay? All right, so now looking at 7 pi over 4, last example. So let's draw a sketch of where we are. So I know this is pi. This is 3 pi over 2, or 1.5 pi. And this is 2 pi when I get all the way around. 7 pi over 4. 8 pi over 4 is 2 pi. So if I go all the way around, I know I'm in this quadrant. Okay, I'm in quadrant 4. 4 is all students take calculus. C, that's cosine is positive. So that means that sine of 7 pi over 4 is going to be negative. Cosine of 7 pi over 4 is going to be positive, and tangent of 7 pi over 4 is going to be negative as well. Okay, so now what's the reference angle? The reference angle, because I'm in quadrant 4, is going to be taking 2 pi minus the angle. So what's 2 pi minus 7 pi over 4? Well, if I multiply this by 4 over 4, I'm going to get 8 pi over 4 minus 7 pi over 4, which is just 1 pi over 4. So there's your reference angle. Pi over 4, when you convert into degrees, pi goes on the denominator. 180 over 4 is 45 degrees. So there's my reference angle. So this is the angle I'm using to reference. That's a 45-degree angle. Okay, 45 degrees means I'm going to use my 45, 45, 90. So here's a 45, which means this is x, this is x, and this is x root 2. Now I went positive x and negative x since I'm in quadrant 4. Okay, so if I take the sine of the reference angle, so coming back to the origin, opposite over adjacent is negative x over x, which is negative 1. No, I'm sorry, I did tangent. Rewind. If I do opposite over a hypotenuse, sorry, opposite is negative x over x root 2. So negative x over x square root of 2, which, remember, okay, so the x's are going to cancel, and I can't have a radical in the denominator, so I'm going to multiply. So I'm going to end up with negative root 2 over root 2 times root 2 is 2. And this is your final answer for sine. Cosine is positive in this case, but it's adjacent. So here's your adjacent over your hypotenuse. Now I have x over x root 2. Well, notice it was the exact same with the exception of the sine as the sine function. So I'm going to end up having the x's cancel, root 2 over root 2 to rationalize the denominator. And so we get, that's not a negative, it's just a radical, 2 in the denominator and root 2 in the numerator, and it is positive for cosine. And then tangent, I already had done tangent, is opposite over adjacent, so negative x over positive x, which is equal to negative 1, because the x's will cancel. Okay, so those are your 3 functions for that angle of 7 pi over 4. Okay, these are all going to come back to be important for us when we start talking about the unit circle in a couple of sections. So get used to seeing these values. I know they're kind of hard to look at now, but they'll get easier and we'll come up with a strategy for memorizing.